we say, are we going to add both equations or subtract both equations? We already identified that they are the what? Same size and different signs. So we're going to do what? Add, right?
Yes, sir.
We're going to add. All right, so we're going to go through this now. So what is it going to give us? 3x plus 2x is what?
5x.
5x. 1 plus negative 1. 1 plus negative 1. This will give us what? 0, right? Sorry,
Yes,
to give us minus. And 1 minus 1 is 0. So we know that actually worked. Okay, next. 18 plus 7 is what?
25.
25. Okay, so what we need to do next? To find,
Make x the subject of the formula.
well, or the equation in this case. And so what we need to do?
Take the 5. I'd take the 5 over to the 25.
Okay, and
It'll become division since
right,
it was
right,
multiplication.
become division. And I like to get rid of coefficient using the balancing method. All right, so it's going to be x equal 5, right? X equal 5, correct?
Yes, sir.
All right, now what do I do now that I found the value of x? What do I need to do now that I found the value of x?
Put it in the equation.
Okay, any one of them, correct?
Yes, sir. Anyone.
All right, so let's go. So we say 3x plus y equals 18. I'm going to substitute x equal 5 in this equation. In fact, let us try both now. Let's try both and see if it actually works. 2x minus y equals 7. All right, so we're going to substitute x in both of these simultaneously and see if it works. So we're going to have 3 times the value of x, which we found to be 5, plus y equals 18. And we're going to do the same thing over here. 2 times 5 minus y equals 7. All right, remember, when you're doing it, you only choose one equation. So you use either this or this, okay? Don't do both, because they're going to put the same answer. Now, all you're trying to do is just solve for it, for y, since you found x. So what would this give us? Tell me. So 3 times 5 is what?
3 times 5 is 15.
3 5 is 15. So 15 plus y equals 18. All right. Let's solve this side and then we go to the other side afterwards. Okay, go ahead. Next step.
So you'd have to carry the 15 over to the 18 if we're trying to make y the subject.
Right. So you isolate the y. So you have positive y equals 18. And what? When the 15 goes over, it becomes what?
Negative 15.
Negative 15, because it was adding over here. So plus 15 becomes minus 15. Good. And so y is equal to?
3.
3. Okay, excellent. And over here we'll say what? 2 5s?
2 5s are 10.
Minus y equals 7. Okay, how are we going to find y?
Next we isolate the y again.
Okay, good.
But we leave it as negative y and carry over the 10 by the 7.
Brilliant. So we have negative y equals 7. And this plus 10 becomes what?
Minus 10.
Minus 10. So we have negative y equals negative 3. What's the next step?
What's next is that we turn the y into positive.
Okay. How are you doing that? There's several ways you can do that, but what method are you using?
Technically, y is actually y is actually 1y, so it's basically negative 1. So we'd have to carry it over as positive 1.
Well, not yet. No. Remember, this is not negative 1 plus y. It's negative 1 what? What is it saying? Negative 1
times y.
Negative 1 times y. So the negative 1 will not change. All right? The negative 1 will not change. Let's write it this way. When you transpose the negative 1, it will not change. The sign in front will not change. Why not? It's the operation you're changing in Othniel. So for example, this, even though we refer to this as positive, think of this as plus. So when you transpose a plus 10, it becomes minus 10. That's why I'm using the term plus instead of saying positive. Because I want you to understand is the operation that changes from plus to minus. Right? Because if you say positive, then when you look at this one, you're going to say this will change. But no. How is, right? How, for example, I should probably ask you this. How is the positive 10, if one think of it that connected to the minus y? It's connected by addition. Okay, it's like you're saying this. It's like you're saying, let's look at this down here. It's like you're saying negative y plus 10, which is the same thing as 10 minus y, because it's like I take the plus 10, put it in front, and instead of saying plus, we just refer to it as positive 10, and instead of saying negative y, we refer to this as minus y. But we're still saying the same thing, right? It's still negative y plus 10. It's still positive 10 minus y. There's both the same thing in terms of the result, right? So I want you to think of it. Think of the operation when you're doing your transfers. So plus becomes minus, multiplication becomes division. So what are we doing here exactly with the negative 1 and y? How are they connected? By what? They're connected by what? Operation. Is
Addition,
it is it subtraction or
multiplication.
multiplication?
Multiplication.
Huh?
By multiplication.
By multiplication, exactly. So even if you were to transpose a negative 1, you would not change it to plus 1. You transpose into the operation change. So negative 3, tell me what to put. Negative
Negative
3,
3 divided by negative 1.
right, divided by negative 1, because we are multiplying negative 1 by y, or multiplying y by negative 1. When we transpose it, right, it divides whatever is on the other side. But it's still the same negative 1 dividing, all right? And that's the reason why I say I like to use and so this is correct, by the way. Let me just finish this off. Y equals, and negative into negative is positive, and 3 divided by 1 is 3. That's the answer. So we got the same answer, right? But that's the reason why I say that I actually, when it comes to the coefficients, I like to just get rid of them by division. So once you recognize that negative 1 is a coefficient of y, to get rid of this coefficient, what would we do? We divide, right? So we divide both sides. It's a balancing method, right? When I say divide, I use a balancing method. I do it on both sides. So I divide negative 1y by negative 1, because that's the coefficient of negative y, the negative 1. So I divide both sides by negative 1. And so I end up with what? A positive y, okay? And negative in negative is positive, and 3 divided by 1 is 3. And so I end up with y equals 3. Got that?
Yes, sir.
Okay, what's another way we could actually do that, though? What's another way we could actually simplify this? I'm going to just remove this quickly. What's another way that we could actually solve this one? What's another way? Okay, let me just tell
Another
you.
way to solve it.
We can
Okay,
trans
divide both of them by negative.
No,
Wait, sorry,
we,
sorry.
we only can divide by negative 1 to get it to be positive y. Any other number will not cancel because the negative 1 is the only number that's multiplying y. But the other option is to transpose the y over, and it becomes positive y or plus y, right? So it's like saying negative 3, and this think of this as negative y plus 0, okay? So when I transpose the negative y over, it becomes plus y. So it's like negative 3 plus y, and we're left with 0 over here. Then I transpose the negative 3 over, and it becomes 0 plus 3 equals y. And so I have y equals 3. Now that's a very long way to explain it, right? But let me show you. But you understood this, I'm certain. But let's look at it in a faster way. Negative y equals negative 3. I transpose this, and I transpose this simultaneously. So the minus 3 becomes plus 3 over here, and the minus y becomes positive y over here, plus y over there. So we have y equals 3. Just transpose both. Got that?
Yes, sir.
Okay, and what's another way we can actually do this? We have negative y equals negative 3. How else can we do this? We can actually multiply this little equation here, this simplified equation. We can multiply it by negative 1, which means we'll multiply the first term by negative 1, which gives us positive 1. The negative 1, remember it's a negative 1 here. When I multiply negative 1 by negative 1, I get positive 1, or positive 1y. When I multiply this also by the same quantity, negative 1, the negative times negative give us a positive, and the 1 times 3 give us 3. So just like we can actually divide both sides by -1, we can actually multiply both sides by -1. Or both, every term by -1. And that will actually give us the same answer. So there's a little technique you can actually use. Just transpose on both sides. I think this is actually a very helpful technique. Got that?
Yes, sir.
Is that now inside of your skill set?
Yeah, yeah.
Right. So you can just draw that, whenever you're ready, you see you have an equation, you say, let's, transpose both of these on opposite sides, and that's it. Okay, so that's that one, right? Let's start.
I would be using the elimination method,
Okay.
but for me to work is that I'm going to have to make the signs on them the same, and I'm going to use the times in method.
Okay. All right. So go ahead. How would you? So tell me, what would you do? Which one you want to eliminate?
I'm going to eliminate the x's.
The x's? Okay. Okay, good. So currently they're not the same size. That's one of the first thing you want. You want them to bring them to the same size. So you're going to use the multiplication method. Okay. So when you say the multiplication method, what do you mean?
I'm going to times the two by I'm going to times 2 by all of equation 1, and then I'm going to times 3 by all of equation 2.
Okay, so it's like you're taking this 2 here, all right, and multiply it by equation 1, right?
Yes, sir.
Okay, all right, and then you're going to take what? This 3 here. Oops. All right, so you're going to take this 3 here and multiply it by what? By equation 2. All right. So, okay, so this 3, take it, multiply by equation 2. Take this 2, multiply by equation 1. Okay, good. All right, so, and that allows us to get what? What's the reason for us doing that?
To make both of the same, so you can start to eliminate them.
Right, so you're gonna get right to get them the same, so you can actually eliminate them. So you're gonna say what? 2 times 3x give us what? Okay, so we're gonna multiply, right, by 2. We can multiply the equation by 2. When you multiply the equation by 2, what do you do actually? Do you just multiply one, like the 21 by 2, or 5 by 2, the 3x by 2, or everything by 2? What do you do?
You have to multiply everything by 2.
Okay.
But like 2 times 3x, and it will give you 6x.
Okay, so 2 times, so you're gonna multiply the 2 by the first term, 3x, and get 6x. Go ahead.
And then you'll multiply 2
To 2 again.
Times 5y, and it'll give you 10y.
10y, okay.
And then you will multiply 2 times 21, and it will give you 42.
Good. All right. So each term got multiplied by the 2. And I suppose we do the same
for the bottom.
Right. In this case, 3 times 2 is 6x. 3 times 3, which give me 9y. And 3 times 13, which give you 39. Okay. And what do we do next?
And to eliminate them, since both of them are the same and they have the same powers or the stuff, to do so, you're gonna have to take away.
Right. Excellent. So because these are the same numbers, right, or same terms, you're saying subtracting them will cause them to become 0. Right? You're taking 6x from itself, bring it to 0. All right. So when I do that, when I subtract 6x from 6x, what do I do with the other like terms, like the y terms?
You do the same.
Same subtraction?
Yes.
Okay. And I guess the constant, the same thing too, right?
Yes, sir.
Okay, good. And so 6x, this one, 6x from 6x will give us 0. Right, good. And I will just draw a line through that, right? To make it easy. And then 10y minus 9y will give us what?
Y.
Will give us y. And 42 minus 39 will give us, 3. Okay.
3.
So, and then what do we do after that though? Now that we found the value for y, so the y's are no longer unknown. The value of this y here is 3. Likewise, this y here is 3. The y's have the same value. Also the x's, but we do not know what x is. The x is. So how are we going to solve for x now?
Now you're going to substitute
Okay.
y equals 3 into, I'm going to use equation 1.
Okay, so you're going to take equation 1, this equation here, and you're going to put this value of 3 in it, right?
Yes,
So
sir.
wherever we see y, you're saying wherever we see the y, we're going
It's
to
going to be
right, we're going to replace this
3
y with
with 3.
3, right? Oh, okay. But question though, could I use equation 2 as well? Would it give me the same answer or a different answer?
It would give you the same answer.
Okay, so we just choose based on convenience, depending on what it looks like, or it doesn't matter. So we're just gonna use that one. Okay, so let's go ahead and do that one. Let's take the 3x plus the 5y equals 21, and we're gonna replace the y with 3 as I said. So we're gonna substitute
Yeah.
y equals 3 in that equation. So we have 3x plus 5. What do I do here?
Bracket 3.
Bracket 3 equals
Mm-hmm.
21. Okay, good.
21.
Right, and you're indicating here that this is saying 5 times y, so we maintain that by saying 5 times 3. Okay, good. And so we get 3x plus 15 equals 21. What's my next step?
Then you're going to switch over or
Transpose.
transpose the 15 over to the 21 because it's transposing over the equal sign. The power will change. Or
Right.
will change.
So the operation of plus will change to what?
Minus or mhm.
Yes, minus or subtraction. So we're adding 15 on this side, and when it goes over, we're subtracting 15. Good, good so far. And so we're saying 21 minus 15 is what?
6.
6. Okay, so 3 times a number, 3x means 3 times a number x equals 6. That number is what? Okay, 3 times a number give us 6. What's that number?
2.
2. Okay, great. All right, so we're going to get that by doing so 3 times x equals 6. All right, and we can do it two ways. All right, so we use balancing method, right?
Yes.
We'll divide this by 3 and divide this by 3. And so we're going to get x equal what?
2.
2. All right, excellent. X equal 2. All right, so we found the value of x and found the value of y. And we had y here being equal to what? 3. Yes, so we have y equals 3 as well. So that's our two solutions. All right, but what if we're not certain that our answer is correct? Is there a way we can actually find our answer? How would we know if our answer is correct? How would we know if our
When
answer
the
is correct?
answer is correct, we can use the 2 that we get, the 2, and we can substitute it back into the both equations and work it out and see if we get that.
Right. So you're saying that we can take both equations, for example, the 3x plus 5y. Let's try that. The 3x. This is just checking our answer. We finish here really, but let's see. We can check 3x plus 5y. Let's see what we get. 3 times x. The x value is 2. 5 times the y value of 3. And so we can actually multiply this. So 3x or 3 times 2 gives us 6 there. And 5 3 is 15. 6 plus 15 gives us 21. Is that the original equation? 3x plus 5y equals 21? Yes. Let's try the next one. 2x plus 3y equals, let's see if we really get 13. 2x plus 3y. 2x plus 3y. And we say 2 times the x value of 2 plus 3 times the y value of 3. 2 2's 4. 3 3 is 9. And 4 plus 9, we get 13. Okay, great. So, and that's that. So we're given these two equations. We're asked to solve simultaneously. How would you go about doing this one? Any ideas? We have this equation. And we have this equation. I know this looks a lot different. But if you think about it enough, you realize we probably just have to do something to it to get it to what we're accustomed to see. How do we go about working this out? Any ideas?
So I think you're supposed to like transpose it, or I remember I was telling you about the one where you create a third equation. Is it this one?
A third equation?
Yes.
The substitution method that we looked at, we transpose and create a third equation, yes. So well, you can say we create a third and fourth equation, actually, yes, from this as well. So we'd have to do what? transpose. So how would we transpose though? What terms would we transpose?
over.
Right, transpose y terms over. Very good. All right, so let's look at that. So when we transpose the minus 3y over, what would it become on the other side here?
Plus 3y.
So we have 4x plus 3y equals 17. Very good. How about the next one? So let's call this equation 3, which comes from equation 1. But it's the same equation, really. Nothing really changed. The values of x and y remain the same. Okay, let's look at equation 2 now. Do we need to shuffle that one up as well?
You can transpose the 4 over. No. Yes.
You're correct.
Okay.
And anything else? So we have 5x, sure. And you say transpose the negative 4 over, and it becomes what? Positive 4.
Yes, and trans over the 2y, and it become negative 2y.
Okay, good. Very good. All right. And think about the operation. I know that you're looking at it as negative and positive, but and that's okay. But think of the operation. So the plus 2y goes over as minus 2y, and the right, and the minus 4. Because if you're reading this, you're saying 5x minus 4, right? So the minus 4 becomes plus 4 on the other side, but we have nothing over there, so just treat it as they're saying positive 4. So I guess we can use those terms interchangeably depending on what we have. And as long as we know that is the operation that we're really changing. Okay, so we have two new equations, not necessarily new, they're just derived from the original equation 1 and 2. And so we're at a familiar place. Okay, so which ones do you want to eliminate, x's or the y's?
Can we try with the y's?
Excellent. I'm happy that you said that. I was hoping that you would say that. All right, so let's eliminate the y's. Because now they have opposite signs. Great. How are you going to get rid of the y terms?
Same as I did before with the x, you have to make them equal.
Right, in terms of the size, right? Okay, so this is, we have 3 and we have 2. Okay, so we want to bring them to the same size, correct?
Yes, sir.
Right, so we'll need to do what? So we need to, as you said the last time, you take the number 3 here, right? And that's what you'll use to multiply the equation. So we're going to multiply equation 4 by what? The number 4 is just saying that this is a fourth equation that we have. And that equation 3, the 3 just indicate this is the third equation we have. We're not literally multiplying 4 and 3, but just the equation itself is what we're multiplying. Just saying that for the audience though. So the 3 here, we're going to use it to multiply this fourth equation. All right, and you say take this 2 that we have here, I multiply the other equation, right?
Yes, sir.
Right, multiply. So we're going to multiply the next equation, the one at the top, by the 2. And of course, if we think about it, it allows what? It allows us to have the same quantity of y's. Because look, the 2 times the 3y will become 6y, and the 3 times the 2y will also become 6y. So that's the reason why we're doing it. 3 times 2y is 6y, 2 times 3y, 6y. So another way you can think of it is bringing them to the LCM, or multiple. Any multiple is fine, but LCM is always best. We want small numbers. Okay, so then the last time you said actually to multiply 2 by each term, correct? For example, this number that we have here, we're going to take it and multiply each term. So I remember you said we multiply by the 4x, multiply the same 2 by the 3y, multiply the same 2 by 17. And so we get 8x plus 6y equals 34. All right, do the next one. You do the next one.
3 times 5x is 15x.
Good. Next. And 3 times negative.
Sorry, by that 3 times negative 2 is negative 6y.
Good. Good.
And 3 times 4 is 12.
All right. Awesome. But here's my question though. Should I have multiplied this equation here by -2 or it doesn't matter?
You can multiply by negative 2 if you want to, if you do not want to make their stuff negative to make it easier to eliminate.
Okay.
You can,
You could,
but you
right.
don't have to.
So, right, you don't have to. So whether they're both -6y or just 6y and -6y, it means that we'd have to do two different things here. So if we had to use -2, for instance, this plus 3y, when multiplied by -2, will become -6y. And so we'll have two -6y, right? So we'll have -6y here and -6y. So here's my question though, right? If we have, let's say let's say we multiply by -2 instead of the 2 itself, right? Would have gotten -6y. So both would have -6y here, sorry, and here. So what would we need to do if we have both -6y? Add or subtract? Do we add both or subtract them in this case?
Add.
We add here or do we subtract? Okay, let's try with a calculator. Put in the calculator -6 plus
Sorry, you
negative.
subtract.
All right, good. Because if you add, then -6 plus -6 will increase the amount of negative you have to -12. You're adding -6 to -6. You're increasing the amount of negatives you have. Or if you want to think of it, when you have the two signs here like this, it becomes subtraction. When a plus and a minus next to each other, it becomes subtraction. It's like saying positive times negative is negative. All right, I think you can think of that as subtraction. All right, or adding a negative give you a negative. All right, so all right, add in negative, give you negative. All right, so I'll give you more negatives. So basically, -6 minus 6 will be -12. And if you use your calculator, that would actually show that. And you quite rightly said subtraction, right? So -6, if you're taking a number from itself, if it subtracts -6 from itself, you should get 0. Whenever you take a number from itself, because you actually have -6, and you're taking it from itself, you'll actually get 0. So yes, we could have done that. We could have multiplied the first equation 3 by -2, and so we would end up with -8x, right? If we had -2 here, this would have been -8x, -6, and -34. And so we would have basically subtract the two equations after because we want to get them to become 0 in terms of the y terms becoming 0. -6y minus 6y will give you 0. But that's not what we have. That's just highlighting what would have if we had to use -2. Okay, so that's it. So basically what we end up with is plus 6y and we have a -6y. So what are we going to do in this case? Add or subtract? Will we add these two or will we subtract them? We have
You add them.
add them. Very good. So if we add -6y to positive 6y, we'll end up with 0. Because with the plus and the minus together here, or the plus and the negative together here, we end up with minus. So it's positive 6. So now we're subtracting 6 from itself. 6 minus 6 give us 0. Alright? 6 minus 6 give us 0. Okay, so that's what we wanted to do when they're opposite. We add. So we're going to add opposite sign in the sense of opposite signs with same size, 6, 6, and opposite signs. So we're going to add throughout. Once you add here, you must add throughout. If you subtract throughout. Okay, let's go. 8x plus 15x will give us what? 23x. And this part will actually give us 0, right? As we highlighted before. And 34 plus 12 will give us 46. How do we get rid of the 23?
You can use the balance method.
Right, so we're going to divide both sides by 23. And so 23 into itself goes once. And I put x equal, and 23 into itself goes once, into 46 goes 2 times. And so we have x equal 2. All right, and now to find y, right, we're going to substitute it in one of these equations. Which equation do we want to use? Okay, we have equation 1, 2, 3, and 4. Does it matter which one we use? No, right? No, right?
No, it doesn't.
Which one would you use though to find y? Which one is you think is the coolest one to use? Equation 1, 2, 3, or 4?
To me, I would have used 1,
Okay. But then if
but
you use
2 looks better. I'm not sure
yes,
why.
you're right. 2 looks better because you're only gonna need to divide by 2 to get rid of the 2 from the y, right? This one. You only need to divide. After you put in the value for x, you just need to divide both sides by 2. But for this one over here, you have to get rid of the 17 and then divide both sides by -3. So yeah, let's look at equation 2. 5x minus 4 equals 2y. By the way, any one of them can be used, even equation 3 here and equation 4. So 5x minus 4 equals 2y. And then we're going to substitute 5 times 2 minus 4 equals 2y. 10 minus 4 equals 2y. And this is going to become what? 10 minus 4 is what? 6. So you're saying 2y is equal to 6. Same way as reading it from left to right. Right to left. 2y equals 10 minus 4, which is 6. Okay, so how do we get rid of the coefficient?
You use the balance method again, so you divide 2y by 2.
Right,
And you
2y
do
by
the
2.
same for 6.
Right, and you're going to get 2 into 2 goes once and get y equals 3. All right, awesome. All right, this is good. I think we would have covered every aspect of this. All right, we would have covered every aspect of this concept. All right, so thank you so much. I'm gonna just make a video now for the substitution method.